Okay, so let us define a subgraph of G. So let G be a graph, and a graph H is said to be a subgraph of G if the vertex set of H is a subset of vertex set of G, and edge set of H must be a subset of edge set of G. So look at this example. I have a graph G here. I have 7 vertices, namely V1, V2 up to V7, and I have 8 edges from E1, E2 up to E8, right? So here I considered a subgraph of that. Out of 7 vertices, I considered only 5 vertices here, and out of 8 edges, I considered only 5 edges here, right? So this is also one of the subgraph of G. I can say that this graph is itself a subgraph of G, right? Fine. And let us discuss about the induced subgraph of G. A subgraph H of G is said to be an induced subgraph of G if each edge of G having 8 endpoints in V of H is also an edge of H. See, how can you form an induced subgraph of G? So this is the graph G, and I am forming an induced subgraph of this. The idea is very simple. The rule is same to construct a subgraph, but instead of picking only two distinct vertices, so in the main graph, if those two distinct vertices are incident with an edge, so we have to consider that also. See here, so I have a graph G, right? And this is an induced subgraph of G. Look at here, I have V1, V2. Between V1, V2 I have E1, so I consider that also. And I have E2, E3. Between E2, E3 there is E2, there is an edge E2. I consider that also. And here I have V5, V6. Between V5, V6 there is no edge here. So I just didn't consider that here. So this is an induced subgraph of G, right? So look at this example. This is not an induced subgraph of this. The reason is, see, I considered V4 and V3, right? In the main graph, between V4 and V3, I can see an incident edge E4, right? But in this example, there is no edge between V3 and V4. So that's why this is not an induced subgraph of G. However, this is a subgraph. Both of them are subgraph of G. Fine. Now let us define a spanning subgraph of G. So spanning subgraph of B means it is a subgraph of spanning subgraph of G is a subgraph of G. But the condition is the subgraph must contain all the vertices of G, right? So here this is the main graph G, and I am calculating the spanning subgraph for that. So here look at this. This is the spanning subgraph of G, right? This is the spanning subgraph of G, and look here, it contains all the 7 vertices. Okay, fine. And let us define a clique. So clique of G is what? Is a complete subgraph of G, right? So a clique of G is a maximal clique of G if it is not properly contained in another clique of G, right? So I have a graph of G here. So let us discuss about the cliques of G. That means the complete subgraph of G. I can consider this line. This is one clique of G, and I can consider this line. This is also one clique of G, and I consider this triangle. This is also one clique of G, because this triangle is what is a complete subgraph of G, right? So like that I can consider the cliques here. So here in this example, this triangle is what is a maximal clique of G, right? And this line is a clique of G which is not maximal.